So with angle relationships, there's typically various approaches you could take, but whenever I see a figure like this, I definitely want to lean heavily on the concept that the radius is congruent to any other radius within the same circle. And in this case, what I would do is I would go ahead and extend this radius here, and then as a result, I would know that it is congruent to each of those other radii. And so I have a couple of isosceles triangles on my hands. And that means that if this is 20, this is 20 because of what we call base angles theorem. And then in this other triangle, if this is 40, then this is 40. Now the reason that's beneficial is because now I know that this angle C is 60 degrees. Now an important distinction when it comes to angle relationships within a circle is we have the difference between a central angle and an inscribed angle. So let's do a quick comparison. If I had a central angle, whatever the measure is of that central angle, I'm using an easy 90 here, that's the same as the measure of the arc. If, however, instead of having the vertex at the center, which makes it a central angle, if instead I have the vertex somewhere on the circle, so let's say, for example, I have the vertex here, and then I'm going to draw a couple other points, connect them, and then we have what we call an inscribed angle. This one was central. So notice you could see this is a semicircle, right? So this is 180 degrees. And then what is this angle? Oh, well, you could see it looks like 90. And the relationship there is the inscribed angle is half the intercepted arc, or you could say the intercepted arc is double the inscribed angle. So now we have 60 as the measure of this inscribed angle. So the intercepted arc is double that. And we're trying to find x, which is a central angle, which means it's congruent to or the same as the intercepted arc. So x is 120.